Welcome everyone back to section number 8. This is issues with Newton's method. That's right? Newton's method doesn't always work. It is an algorithm, so sometimes it doesn't converge to the thing that maybe you would expect. And we just have this one page here. It should be a nice short video, but let's get to it here. I have 3 Desmos apps that we're going to bring up and kind of talk about. So let's go ahead and bring up the first one here. So in this case, notice what happens. Right, we start off, the idea is that we're starting off right here. This is maybe my initial guess. And then when you travel along, you try to figure out, again, we're trying to find the zeros of this function. That's what Newton's method does, is it's supposed to find the zeros of the function. Right, so maybe we're trying to find this 0 right here. So we have this initial guess, but you can see what happens actually is that this tangent line crosses down here. So this becomes our second guess. And so when you go to the function at this point, for our second guess, the tangent line at that point is horizontal, right? And so that's the first thing that can go wrong. If you have a horizontal tangent line, well, it will never cross the x-axis, and so it just stops. So let me go ahead and write this down for us. So the first problem that we can have is a horizontal tangent line. And this actually will appear in the algebra as well, right? A horizontal tangent line means that the derivative is equal to 0 at that point, right? So it has a derivative equal to 0. Now, if we go back up here and we look at our theorem for Newton's method, how do I get our next guess here? Well, notice that you have to divide by the derivative. So in this case, you'll be dividing by 0, and it says, well, this is an error, right? That doesn't work. Right? So in this case, that's kind of just Newton's method, game over. There's nothing more to do. You maybe need to alter your first guess a little bit. So you can see in this case, right, if I was to just move this just even a little bit, right, things work out. Right? Just move it a little bit, and we can start finding some of these roots. But as I had it originally, right, we have a horizontal tangent, and so it's just kind of game over. All right, so that's what can happen in this first case. If you have a horizontal tangent line, you're dividing by 0, that doesn't work. Next one that can happen. So again, I already have these preloaded, but you may want to type these in and kind of play with them yourselves. So we have a different function here, and again, I'm trying to find where it crosses the x-axis, right? Where is there a 0? So maybe I'm trying to find this point right here, but you notice that I'm just a little bit over this hump. Right? Just a little bit over this hump. So actually the next place that it crosses is down here. Let's go ahead and add in our second point and maybe my second tangent, right? And it's actually keeps on going over here, right? So it's getting farther and farther away. I can add in a third point and a third tangent, and that one crosses even farther down here, right? This is getting farther and farther away from what I wanted to get to. And so as we go farther and farther this way, you can see that actually we have one of these horizontal asymptotes, right? It never actually quite crosses the x-axis over here. So it's getting farther and farther away from its root, from where it does actually cross the x-axis. All right, so that's the second thing that can happen. I usually call this that it never converges. And this is one way that that happens. So it doesn't converge to anything in particular, right? It just keeps on going, and it'll get bigger and bigger, and it'll never cross the x-axis. There are no roots out there. Okay, the final one is right here. So we have a tangent line, and let's suppose, with this initial guess, you'd probably be trying to find maybe this root here, this root at 0. But notice that actually it's kind of jumped too far to the right, and it crosses down here. So there's our second point, our second tangent line, our third point, and our third tangent line. And you can see it is getting closer and closer to a root. It is getting closer and closer to this place right here. But, maybe ideally we would have liked to find the root like -5 or 0. So in this case, it's converging to a farther away root, right? That maybe we didn't care about or didn't want to find. So sometimes Newton's method, it converges to the wrong root. And so that's the final thing that can go wrong with this. It's kind of unexpectedly converges to the wrong root. Now in all 3 of these cases, right, things are going wrong, but the claim is, right here with this remark, is that if you change your initial guess, right, that most of these things can be solved, right? So for instance, if I go back here, and for my last picture, if I wanted to find maybe 0, right, if I change my initial guess, if I just move this a little bit, right, that we can find a way here that now it's actually getting closer and closer to 0, right? That red line actually crosses very, very close to 0. Or maybe if I was trying to find -5, right, if I change my initial guess, there we are. Now all of these are like getting closer and closer to -5, right? So here's my second guess. My second guess gives me the third guess. The third guess gives me the fourth guess. That's pretty close right there. So again, by changing our initial guess, our x1, we can actually fix most of these cases. So that's to say, if you do go out and build an algorithm to do Newton's method, right? If you know a little bit of programming and whatnot, if you end up getting an error, right, well, just change your initial guess. Have it do, a different random number that's maybe close by. All right, so that's how Newton's method can fail. That's it for section number 8. I'll see you guys next time.